Guys, it's me again. Welcome to episode 83 of the ADHD superpower. Today's episode is a little difficult to digest if you're not a scientist, so listen carefully. It's ADHD and structural impairments. The structural brain impairment in ADHD is a neurological development disorder, and its behavioral manifestations are caused by underlying structural deficits in dispersed brain areas, mainly in the frontal region and the basal ganglia. The frontal cortex is mainly involved in the high-order functions such as attention and working memory, learning and motivation, as well as planning and decision-making, which seem to be impaired in ADHD. The basal ganglia, on the other hand, is mostly involved in behavior and motor control, as well as the planning and controlling movement learning, which also impacts Parkinson's disease. It also might contribute to the hyperkinetic impulsive behavior seen in ADHD patients. A review of MRI study in children with ADHD found converging evidence from the literature that children suffering from ADHD have significantly smaller brain volume globally, including reduction in the size of frontal and prefrontal cortex at the basal ganglia. Brain volume seems to be correlated with the severity of ADHD symptoms, as smaller size increase symptoms of inattentiveness and hyperactivity. The prefrontal cortex, or PFC, in particular, is considered a center for executive control behavior, cognition, and emotion, and is also involved in more complex tasks like reasoning and adhering to social norms. The caudate and the putamen are also specifically involved in learning and goal-directed behavior, be responsible for more flexible and adaptable behavior, while the putamen plays a role in simpler habits and stimulus response association. Impairments in these regions may contribute to the learning and self-control difficulties particularly encountered by ADHD patients. Diffusion tensor imaging (DTI) studies also show structural connectivity abnormalities in frontal structure and frontal parietal white matter tract in both adults and children. In addition, longitudinal studies point to the fact that ADHD features a delay of about 2 to 6 years in structural brain development, especially in the cortical thickness and surface area of frontal and parietal regions, among others. This is presumably connected to the delay in neurological branching, followed by a delay in pruning and myelination in ADHD. Almost done. Impairment of these functions is likely to lead to inattentiveness or impulsive symptoms as seen in ADHD patients. Overall, there appears to be a delay in the maturation and development of the brain in ADHD patients, with some cognitive function taking longer to develop compared to healthy controls. These lags, almost done, seems most pronounced in frontal regions, which are associated with exerting consciousness control over other brain functions, including response inhibition, foresight into the future, and self-regulation. It has been suggested that structural delay and disruption in brain circuits in ADHD may be linked to genetic factors involved in the disorder. Thank you very much. Have a great day.